and logarithmic functions, and these two are quite interesting also. So we can define this exponential function first. That is, exponential function is with a positive base. I'll take it as a b and which is greater than 1. Okay, it is a positive one. Is a function y is equal to f of x is equal to b over x. So now I'll take this base is a positive number and I'll take it as a 10, that is a 10 over x. So now the graph of this 10 over x will explain some features of this exponential function which are like. So domain of this graph is nothing but exponential function with a base 10. So domain of this is, it is a set of all real numbers. Then the range of this exponential function, which is a set of all positive real numbers, and the point 0, 1, which is always on the graph of the exponential function. So if you consider that any graph, this is the graph, and there will be a plotting of this one, and there is a point that is 0, 1. So you can consider that a graph. Okay, it is on this 0, 1. You can say that, okay, this is what a exponential function graph. So with the help of that, I can say that the point 0, 1, which is always on the graph of exponential function. Okay. Next, I can say that this exponential function is ever increasing. Okay. And lastly, I can say that this a very large negative value of x. So this one, if you consider a large negative value of x, then this graph which is closer to 0. Okay, if you consider a very large negative value of x, then the graph which is closer to 0, or I can say that in the second quadrant, particularly in the second quadrant, the graph which is approaches to x-axis. Okay, but it never meets it. Okay, which is close to 0. Or I can say that this is in a second quadrant, particularly in a second quadrant, the graph of this exponential function approaches to x-axis, but it never meets. Okay, so this is what a exponential function when you consider the base is a 10. So now with the help of this one, I can say that. So if I consider the exponential function and its base is a 10, and then such a function is called as natural exponential function. Now I can consider there is a sum of the series, then such a series is nothing but 1 plus 1 divided by 1 factorial plus 2 divided by 2 factorial plus etc. This is what the series, and this series will give the number, and that number is between 2 and 3. Okay, for this series you will get a one number, and that number is lies between 2 and 3, and it is denoted as small little e. Okay, with the help of this e, we can define a function that is y is equal to f of x is equal to e over x. This is extremely important and which is called as an exponential function. Okay, exponential function is nothing but e over x. In a standard way we can denote it. So now the inverse of an exponential function exists, and as a nice interpretation is nothing but the next definition, which is logarithmic function. So how can we define this logarithmic function? With the help of this graph is nothing but, again the logarithmic function is also a function. I'll take y is equal to log x. It's nothing but it is a function. Log is a function. So function, and it is from the positive real number to set of all real numbers. So log function is from positive real number to set of all real numbers. So first we will consider only the positive real numbers, and that may be mapped to either a positive real number, either a negative real number. Then such a function we call it as a logarithmic function. So again with the help of this graph, I can say that a few features of this logarithmic function. So first one is, so domain of this logarithmic function is also a set of real numbers, and the range is also a set of real numbers. Again, this logarithmic function is also a increasing function. Okay, it increases. And so as I said that in an exponential function there is a point which is always, that point is 0, 1, whereas in a log function which is 1, 0. So if you observe these 2 points, you can say that, so graph will approaches to x-axis in an exponential function, whereas in a logarithmic function the point is 1, 0, right? So now you can say that this logarithmic function which approaches to y, okay, it approaches to y but it never meets. So this is what a slight difference between the exponential and logarithmic function. So now we have important properties of a log. Okay, we'll just make use while solving the problems. Okay, I'll just list out here. So before that, I'll just write the derivatives of exponential as well as a logarithmic. So d by dx of exponential is nothing but e power x, and its derivative is e power x itself. Okay. Next, d by dx of log x is nothing but 1 divided by x. This is the derivative of exponential and this is the derivative of logarithmic. Now, properties of logarithmic functions. So first one is, I take the log and 2 functions m and n, different functions, where these 2 functions are like a product. In that case, we can write it as log of first function plus log of second function. So here, this is the one property. Next one is log of m divided by n. It is the log of 2 functions, whereas these 2 are like a quotient. We can write this as a log m minus log n. This is the second property. And the third is log of m power n. One function and it is a power of some positive number. You can write this as a n log n. These 3 are the properties of logarithmic function, and we'll just make use of these properties while solving the problem. Is it clear? So now, what we will do is, we'll solve some simple examples which is based on the exponential and logarithmic. Then we'll just go with the exercise problems. Okay? So example is, I will say differentiate with respect to x. So first one in that, differentiate the following with respect to x. First one is e power minus x exponential. So how can we differentiate this x? So as we know that the derivative of exponential function is exponential itself when it is only a x. If it is the power of a e is the different, it's nothing but, so d by dx of e power minus x, we can write this as, so if the function is an exponential, while differentiating that one, we just write the given function as it is first. This is nothing but the derivative of this is e power minus x. Write the function as it is. Next, what you will do is differentiate the power of that exponential. Okay, power of this exponential is minus x is there. If it is only a positive x, then you could have write it a derivative is e power x only. Why? Because it is a minus. So positive x. X derivative is nothing but what? It is a 1. So 1 into e power x will be e power x only. But here the case is different. The variable x is with a negative sign. In that case, you should differentiate the power of e. Again, the minus x. Derivative of minus x is nothing but minus 1. Clear? Hence we can write minus e power minus x. Clear? Derivative of exponential function is nothing but, so we just write the function as it is. Again differentiate the power of this e. Okay, whatever the power of e, it may be a some polynomial, or it may be a some trigonometric, or it may be a log, or it may be a inverse trigonometric also. So in that case, write the function as it is. Again differentiate the power of this e. Okay, this is what the derivative of the exponential function. Clear? So second one is e power cos x. So derivative of e power cos x is, write the function, given function as it is, exponential. So again what you do is differentiate the power of a e separately. So power of e, we have some trigonometric function, that is a cos x. It's nothing but e power cos x. Derivative of a cos x is what? Minus sin x. As you can write, the derivative of this e power cos x is minus sin x into e power cos x. Hope you guys getting these points. Okay. Next is sin of log x. Exponential is there, cos inverse. So find the derivative of cos inverse of e power x. Don't mess up with the thing. So your first is the inverse trigonometric is there, then it is the exponential. Okay. So as I said that exponential function is there, means write the function inverse function. So for that derivative you need to write the variable is nothing but exponential. Again differentiate the exponential. Clear? So cos inverse derivative is what? Minus 1 divided by square root of 1 minus x square it is. So in the place of x we have an exponential, right? You just write e power x whole square. Now what do? You need to differentiate this inner function again. So d by dx of e power x. Clear? So now minus 1 divided by square root of 1 minus e power 2x I can write. Okay? Into derivative of e power x is e power x only. X we can write minus e power x divided by square root of 1 minus e power 2x. This is what the derivative of a given inverse function along with the exponential. Okay. So last one is in this. Differentiate with respect to x. The function is sin of log x. Sin of log x is, again which is a composite function, right? Sin function, again log function is there. So differentiate the sin first. For its derivative, you just write the variable is nothing but a log. Again differentiate the inner function log. So sin derivative is a cos. You can't write it the cos x because the inner function is log is there. Therefore cos of log x. Again you need to differentiate the inner function, that is log x. So as I said that the derivative of log x is nothing but 1 by x. Hence we can write the cos of log x into 1 over x. Or you can write 1 over x into cos of log x. So this is what the derivative of a given sin of log x. Hope you guys understood the exponential and the log. Okay, it's a little theory, but in your exam they'll ask you problems. Okay, hope you guys understood this one. So we'll solve the exercise problems in the next class.